The trigger selector schematic is pull-out schematic 4 and is enough different from the standard 7000 series display switching that we'll discuss it on this tape. Now here we take the output from the left and right trigger takeoff from the left and right vertical preamplifiers and supply an A and a B trigger for the A and B time base units. In addition to that, there's an A auxiliary and B auxiliary trigger for dual time base plug-ins. And then there's the vertical signal out information, which goes to the signals out board and then to the front panel vertical signals out jack. Now we use two of these new high-speed switching ICs that were designed especially for this instrument. That's the MO71. These are tech-made ICs. Well, let's look at the top one, U525. Now as inputs we have the push-pull left trigger takeoff signal in at pins 6 and 8. Notice the signal polarity markings on the schematic. Then the right plug-in inputs. Then just below pins 14 and 15 are the command lines. Now pin 14 will be high when we're using right trigger, low when we're using left trigger, and when pin 15 is high and pin 14 is low, then we add the two triggers. Now pins 4 and 5, 10, 11, 16, 17, and so on are emitter lines, and you notice the labeling there, where between pins 4 and 5 we have a left minus. Well, that associates those two emitters with the corresponding bases at pins 6 and 7 at the inputs. Now right between pins 4 and 5, or between those emitters, is a 21.8 ohm nichrome resistor. Now we could use that resistor value to calculate the gain of the amplifier within this switch. However, the amplifier is an FT doubler, so you'd come out with twice the current that you would expect. Now between pins 1 and 2, there are two 50 ohm resistors in series. Now the junction of those resistors doesn't tie to any external pin, but is used to divert current within the switch. The external current load is quite constant on this IC. Well, that 50 ohms then, in parallel with the external 50 ohms, are 537, for example, means that we have a 25 ohm source impedance to drive the output amplifier. VCC for the IC is pin 3. It sets at 2.6 volts. Notice the voltage setting device. Q521, it's temperature compensated by CR519. On the lower left-hand corner of the IC, pin 13 is the emitter return for the switching portion of the IC. Let's look over at the left margin where the left and right triggers come in. These are push-pull triggers with a signal value of 50 millivolts per division push-pull. They go into a series of power divider T's with 50 ohm characteristic impedance. Now there's a loss there, which we must make up in the IC switch amplifier and the output stage, such that the signal output at pins A20 and B20 is also 50 millivolts per division push-pull. Now notice that that line is reverse terminated in R553. Well, perhaps we should look in a little more detail at that amplifier. R552 is a thermal balance resistor, bypassed as usual by C552. Notice the centering adjustment. It assures us that in the absence of input signals, that A20 and B20 would be at the same potential. Now the overall gain of the amplifier is set by the gain adjust, R549, in between the emitters of that output stage. Now there's one down at the B amplifier, of course, as well, and aids us in matching the A and B trigger output levels. There's some high-frequency peaking also in R546 and C546 in between the emitters. And notice the line that takes off goes down below where it says B auxiliary trigger. Well, that drives the B time base if in an A compartment you have a dual time base plug-in, such as a 7B53A or 7B92. Let's look a little more closely at the inputs there to the A trigger channel switch. Pins 8 and 9 are tied together inside of the IC, as are pins 6 and 7, 18 and 19, and so on. Now the lead inductance in series with those leads form a T-coil, an inductor, for example, in series with pin 8, one in series with pin 9, and C510 provides a conventional shunt across that T-coil. Pin 9 then terminates that line. Well, let's drop down to the lower right-hand corner where we have a near identical circuit. We take off from right at the output of the IC, however, with the vertical signals out information, which goes to the signals out board. Now you notice we don't have the 50 ohm termination off pins 1 and 2. That's found over in the vertical signals out circuit. Now if you'll turn in your manual to table 1-2A and table 1-2B. Now I don't know at this time what page those tables will be on. There you'll find the input and output combinations for the trigger select logic. Table 2A is for A trigger and 2B for B trigger. We'll use the 2A table for most of this discussion. Okay, if you have that handy and have the schematic 4 pulled out, let's locate the switches. Now just above center is the A trigger source switch. We'll begin with that. Then just to the left are the logic lines from the vertical mode switch. Notice that we have just the 3 lines, add, alternate, and right. Well, when we've selected right, then the right line is high. When we've selected left, then all 3 lines are low. When we've selected alternate, the alternate line is high. Select add, that line is high. When we select chop, all 3 are low, which tells us then that the trigger selection for the chop mode is the same as for left vertical mode selection. Now let's go back up to the A trigger source switch. Slightly to the right and just below are a couple of pilot lights, one of them marked R for right and the other one just below, DS469, is marked left. Well, those are the push button lights back of the A trigger source switches. Then just to the left there, DS452 is the vertical mode light. All right, let's take that table, 1-2A. Now the first column is the A trigger source switch positions. The next one is the vertical mode switch positions. And the next one, horizontal slave enable, applies only when the A trigger source switch is in the vertical mode position and the vertical mode switch is in alternate. The next one is the vertical mode command line. That comes from the logic diagram, and it comes in just below those 2 left and right lights I mentioned a moment ago, and at the collector of Q472. Okay, the next one is the A trigger logic lines. Now that'd be pins 14 and 15, the add line and the left-right line going into the ICs. and then to the right would be the trigger lights back of the push buttons. Okay, let's take left vertical first. Now when you have selected left vertical, you notice it doesn't make any difference where the vertical mode switch is. It doesn't make any difference where the horizontal slave to enable is. It doesn't make any difference about the vertical mode command. Well, let's begin with the vertical mode trigger switch. Did you find that? Now let's begin with that switch canceled, unlike the way it's drawn. Now you notice we have two ground closures. Let's take the top one first, which goes to the left and down to the junction of R449 and R450. Let's follow that to the right over to the base of Q472. And that base is low. That transistor is off. It does not react to the vertical mode command. Now that's the time that the vertical mode switch is canceled. All right, let's take the next ground closure on that switch and go down, and you notice we pull down on the cathodes of CR 454, 456, 458, and 460. Now with those cathodes pulled to ground, that assures us that the selection of the vertical mode switch doesn't interfere whenever the vertical mode switch is canceled. All right, let's punch up right button now. Now that will cancel left, and that will cancel vertical mode. Okay, we pick up plus 5 volts. That 5 volts comes down a little ways through R465, lifts the base of Q466. The collector comes down, and look up above, it lights the right light. At the same time, in through R467, it pulls down on the base of Q469, turns that transistor off, and we do not light the left light. Let's go back up to the right push button, down through R463, and off to the right, out pin FZ, and up to pin 14 of the IC, U525. And that high in at pin 14 routes the right trigger information into the A channel output. Well, let's look at the table again. Let's see, right vertical is the second item on there instead of the first one. Well, it doesn't make any difference. You see where the vertical mode switch is placed. Remember, we pointed out how the action of the vertical mode switch was shorted out. And the horizontal slave enable, we'll get to that later. And then the next one, vertical mode command, doesn't make any difference. Remember, we turned off Q472, so that transistor wouldn't react to the vertical mode command. All right, now let's punch up left. We cancel the right switch. We get a ground closure there that pulls down on the base of Q466, turns off that transistor, extinguishes the right light. Now as the collector pulls up through that right light, it lifts the base of Q469, turns that transistor on, and lights the left light. Now, since we do not pull up on that line, which goes through FZ over to pin 14, then it is low, and that's the low necessary to route the left trigger to the output. All right, now let's punch that vertical mode switch. One thing it does is to light the vertical mode light, and at the same time removes the ground, which turned off Q472. It also removes the ground, which pulled down on the cathodes of those 4 diodes, and now we're responsive to the vertical mode switch. Well, let's use right. Now that's the bottom one on the table. Okay, the right line is high, which lifts through CR422. Find that? Lifts off to the right there, the base of Q466. Turns that transistor on and lights the right light. And as we know, we'll turn off Q469 and extinguish the left light. Let's go back to that right line. Go down through R426, through CR426, through CR462, through R461, and we're at the bus which goes over to pin 14 and pulls that high. And as we know, that is the right trigger selection. Now the trigger source switch is in vertical mode, and we've punched right vertical. Now let's punch left vertical, and all three of those lines are low. Well, let's just take that right line, which is low. We're not pulling up on the left-right line. It is low, and that passes left vertical. Now we're not pulling up on the base of Q466. That transistor is off. Its collector is up, which in turn lifts the base of Q469 and lights the left light. Now chop is exactly the same. It lights the left light. The left vertical is supplying the trigger in chop mode and in left. All right, let's punch up alternate next. First thing is lifts through CR421, which lifts the base of Q466 and lights the right light. All right, back to the alternate line. Let's go down and off to the right to the collector of Q428. Now that provides a collector supply for that transistor and lifts the base of the transistor, and the emitter follows it up. All right, now that high goes up and off to the right to the base of Q472 and saturates that transistor. All right, the vertical mode command comes into the collector of that saturated transistor. The emitter follows the collector then, and the emitter is tied over to pin 14 of the IC, and it will alternate between high and low, following the vertical mode command, such that the trigger will follow the vertical selection. Let's go back to the emitter of Q428. Now we had a high at that emitter. Let's follow that up through CR447 to the right through CR465. We'll lift the base of Q469, even though Q466 is pulling down on the bottom of R467. You see, this is an override. That'll lift the base of Q469, turn on that transistor, and light the left light. So in the alternate mode, both the left and right lights and the vertical mode lights are lit. All right, back down to Q428. Now, at the time that we supplied that transistor with collector and base current, we also pulled up through R428, which would lift through CR461 and lift that left-right line. Well, we don't want that to happen. We want that thing to alternate, you see, with the vertical mode command. So back to the emitter of Q428. That high at the emitter then lifts the base of Q476, saturates that transistor. Its collector comes down, turns off CR461, and removes that pull-up. So that's an override in the alternate mode. So in the alternate mode, then we've allowed the vertical mode command to control the trigger source, alternating between left and right. We've lighted the left and right lights. Now, if we're in the horizontal slave mode, that'll be either chopped or alternate. And if we're not in delaying sweep. Then we have a high in at the base of Q430. Now in that slaving mode, remember we want the A channel to be supplied from a trigger from the right vertical and B plug-in to be supplied from a trigger from the left plug-in. Even though we're in alternate mode, we don't want to chop between the two. We're slaving the triggers in that manner. So Q430 is an override. Now the high in at the base of Q430 in the slaving mode saturates that transistor. The collector pulls down on the base of Q428. Its emitter follows it down. Now that turns off Q476, which is incidental. But let's follow that low, up a ways, off to the right, and it pulls down on the base of Q472, turns off that transistor. We're not responsive to the vertical mode command. Okay, now let's go back to the collector of Q428. Remember, it's tied to the alternate line. So we pull up through R428, to the right through CR461. Remember, we said that in this horizontal enable mode that Q476 is turned off and does not interfere. It lifts through CR461, lifts the left-right line, and the A time base is getting its trigger from the right vertical. Now, so far we've talked about just the A trigger, but for this mode we need to talk about the B trigger as well. Let's go back to the emitter of Q428, follow to the right to the base of Q484. We've dropped the base of that transistor. It is off and does not respond to the vertical mode command. The emitter is down, and there's nothing else to pull it up, so that places a low in at pin 14 of the B trigger channel switch, and the left vertical supplies the B trigger. Now perhaps you wondered a moment ago when we mentioned that in the alternate mode both the left and right lights were on, why it was that Q469 was driven by a transistor instead of just a logic line. Well, here's the reason: because we want to extinguish that left light now for A trigger and the right light for B trigger. All right, let's go back to the emitter of Q428 again, the low there. Let's follow that up and to the right to the base of Q469. See, we do not have the high pulling up on that transistor, so the left light is out for A trigger. Back to the emitter of Q428. Follow that down through CR479, off to the right to the base of Q500. That transistor is not on. Okay, follow from the collector of that transistor down, and you'll see that when that transistor is on, would light the right light. So in the alternate mode, in the horizontal slave mode, we have extinguished the right light on the B trigger source switch and the left light in the A trigger source switch. Now refer to the two tables, and you'll see that that's true. When the horizontal slave enable is high, remember that's when the horizontal mode switch is in either alternate or chopped, and you're not in delayed mode. All right, the only mode left is add. Now, this is going to be pretty straightforward. Let's take the first line off the add status line, clear over to the right through CR465 to the base of Q469, turns that transistor on and lights the left light. Okay, back to the add line through CR420 off to the right, lifts the base of Q466 and lights the right light. Okay, back to the add line, off to the right through R424, off to the right, and up to pin 15 of the IC, and that combined with a low at pin 14 of the IC will add left and right. Now if you'll trace pin 14 back, you'll find that there's nothing pulling up on that line, so it indeed is low in the add mode. So the switching logic is pretty straightforward in most cases. It gets a little complex in the alternate mode. Let's turn next to plus schematic 8. That's the output signals and calibrator. Let's look at the outputs first along the right side. These, by the way, are the output BNC connectors on the front panel of the instrument. At the top, there's the signal out. Now that follows the B trigger selection. It has a value of about 0.5 volts per division, open-circuited, and about 25 millivolts per division into 50 ohms. Now that means the source impedance has to be 950 ohms. If you look over to the left, you see that the parallel combination of R1022 and R1024 come out pretty close to that. Next one down is the sawtooth out. Now that can be either A or B sweep, depending on the switch selection on the side of the instrument on the calibrator signal board. That's a positive going ramp, about 10 volts into 1 meg, or a half volt into 50 ohms, again approximately 950 ohm source impedance. Next is plus gate, a positive going 10 volts into 1 meg, a half volt into 50 ohms, and depending on a switch selection, again on the calibrator and signal board, can get the output from either A gate, B gate, or delayed gate. Then there's the calibrator volts output and the calibrator current loop. The calibrator volts is either 4 millivolts, 40 millivolts, 0.4 volts, 4 volts, or 40 volts, or the current loop is 40 mils. And it can be either 1 kilohertz or B gate divided by 2, or a DC voltage or current output. Well, let's look at the vertical signal out circuit first. The input arrives push-pull up in the upper left-hand corner, and that comes from schematic 4, so let's turn over there for the moment. And in the lower right-hand corner, you see where it says signal to vertical signals out circuit. Well, that's the takeoff from pins 1 and 2 of U575, and the source of signal is made by